Hello and welcome to C++ Weekly. I'm your host, Jason Turner. I want to remind you that I am available for code reviews and on-site training. Now, in this episode, I am going to discuss this interesting topic that someone brought up. And this is your reminder that I do have a GitHub repository that tracks all of my episode ideas and plans. And you should go check that out and thumbs up video ideas that you like, and add your own video ideas if you want to. This particular idea I thought was interesting, and it's, 3 years old now at the time of recording of this episode. But he says a feature I'd like to see is that if you can have lambdas inherit from a class, so that you could create nameless scoped class types that implement something from an abstract base class, inspired by unnamed classes in Java. Now, this was actually a comment on a video that I made into an issue here. I do strongly prefer that you add the issues here instead of me doing that, so be sure to check those out when you can. This week's episode is sponsored by HRT. If you've attended any C++ conferences this year, there's a good chance you've already heard of HRT, as they have sponsored several conferences. HRT is known for its deep engineering culture and strong focus on performance. And they are looking to hire the sharpest engineers to help them to develop and optimize the technology at the core of their business. They're headquartered in New York, but they have offices in Austin, Chicago, Boulder, London, Dublin, and across Asia. They're looking primarily for C++ and Python developers. I know, since you're a viewer of C++ Weekly, you are a C++ programmer, and you probably already program in Python too. So go ahead and check out the link on the screen for openings that they have. And remember, you don't need a financial background, just strong engineering fundamentals, and they'll teach you the rest of what you need to know. Let's get into this. It would seem that the poster kind of wants something like this. Some sort of way to have a lambda inherit from a base class. And this isn't possible. Yes, it does create a new type for you. But then what do we do with this type? So if I have this lambda here, I can do something like this, and that I can inherit from a lambda. This is something that we have demonstrated a few times on this channel. And in fact, I've got, I think, something on the order of 40 episodes about lambdas. And this is my, quarterly reminder to let you know that if you understand all of the nuances of C++ lambdas, then you understand most of the core of the C++ programming language. So I do strongly recommend that you look into understanding lambdas more. So I can create this thing, but I don't have any way of specifying that the lambda should derive from an object. I've got my derived type here, and my lambda becomes the base class. I could do something even like this. And I can create an object of this type. But I can't actually call this thing yet. Oh, I can call it. Never mind. I can call it because it inherited the paren operator overload. That's correct. The real question that I ended up coming to is not, can a lambda inherit from a base class? It became something more like, can I inject behavior into a lambda? That's what I ended up focusing on here, because I can't specify an interface, and realistically a lambda can only have one function. It has the call operator overload. I can add other functions here. I can do something like some sort of function here, and I can in fact call d.update values, and I can call that call operator overload that the lambda gave me. How can I get this update values and this call operator overload to somehow interact with each other? That's the question that I ended up deciding to answer. And with C++ 23, this is actually possible. In C++ 23, we can do deducing this. Now I have this self object, and this is how we might do recursive lambdas. in C++23. And I've demonstrated this before, but, well, yeah, that's not going to be very helpful, but I could. If I have deducing this and I have inheritance, now I can actually access the members of the thing that I am being used as a base class for. So now I can do something like have this value, and every time update values is called, I'm going to increment value, and inside of this lambda, I can do something like this. I have injected capability into the lambda. I'm calling a function and accessing objects that don't exist yet. I'm assuming that they are going to exist. And I provide them with the derived class as opposed to providing them with the base class. Let's go ahead and move this outside of here. And we'll make the magic overload set for lambdas that we've seen before. So here we have a overload set built from lambdas that have shared state between the lambdas because they can all access the things that were declared in this overload base class thing. This is interesting, and I think it meets the spirit of what the original person asked. And we can share the state, we can have a, I don't know, shared function call count, whatever, something interesting like that. So you can write lambdas that inherit behavior, if you will, and can share state between themselves without knowing anything about the other thing. And then this would all fail to compile if we got part of this wrong. Anyhow, I thought this was interesting. Hopefully you enjoyed this. This will definitely be going in my list of Lambda episodes, and you should absolutely check out that playlist on Lambda episodes because there's just so much to talk about there. Thanks for watching this episode. Be sure to subscribe, and I will catch you next week.